All right, so we're going to look at the area of a parallelogram and triangle. Sometimes the examples are pretty straightforward, sometimes they're a little bit trickier. So we're going to start out with kind of a trickier parallelogram. So this is our parallelogram. We know that the area of a parallelogram is equal to base times height. So if we know the base and height, no problem, we can find the area of this parallelogram. So the base is 10 right there. So we know that the base is equal to 10. What we don't know is the height. This is the height right here. It's going to be the line that connects, the top and the bottom of your parallelogram, and it does form that 90-degree angle, so it has to be kind of a straight up and down line. So that's our height. If we can figure out the height, then we can find our area. So what makes this one a little bit tricky is we don't know the height, and what I do notice is we've got this nice little triangle off on the side. I'm going to go ahead and redraw that over here. If you notice, that is a 45-degree triangle, and it is a right triangle. So we've worked with 45-degree triangles. We know how to label those. We haven't done it in a while, but if you remember, across from, this does not look accurate by the way, but it is 45 degrees. Across from the the hypotenuse of a 45 degree is x root 2, and then your two sides are x. So remember, that's one of our special right triangles. They also told us in the picture that the hypotenuse is 6 root 2. So that means that these two are equal to each other. That's where we're going to put that equal sign and solve. So we're going to say x root 2 equals 6 root 2. You can solve for x by dividing both sides by the square root of 2. Cancels here, cancels here. And hopefully we can see that we are left with x equal to 6. Well, that helps us because that's part of our triangle. That's our height right there. So that's going to be a 6, which means in our triangle, which is the height of our parallelogram, that's a 6. So our height is equal to 6. So sometimes you might have to fall back on prior knowledge to find the missing pieces in order to find the area of a problem. That's pretty common, but that's all right, we can do it. So now the area is equal to, we can plug in 10 for the base times 6 for the height. 10 times 6 is 60, and then because we're labeling everything and there's not a label provided, we are going to write in units, and because it's an area, we're going to get that squared. So the area of the parallelogram is 60 units squared. All right, now we've got this triangle over here. So we see the triangle, we're going to write down our area formula so we know which one we're using. 1/2 base times height. And we just need to know the base and the height in order to find the area of this triangle. So sometimes, if you think about turning this triangle so that the 25 is on the bottom, this actually is the base right there. So the base is equal to 25. And then the height is that line going from the top of the triangle straight down to the base, creating a 90-degree angle. Our height is equal to 12. So we have a base of 25 and a height of 12. So now we can go ahead and find the area. So area equals 1/2 times the base of 25 and the height of 12. If you multiply that all through, sometimes if it's easier just to do 1/2 times 12, you get 6, and 6 times 25 is 150. Either way, just so you're getting 150 as your final answer, we're good. And then they didn't provide a unit, so we will go ahead and write units, and we're going to square that because it is an area measurement.